Hello everyone, we want to solve problems on three charges. In the last class we looked at superposition principles and how it applies to Coulomb's law. In this class we just did the analysis, we did not solve problems. And in this class we are going to be looking at some problems, some interesting questions on three charges, how to resolve net force on one of the charges out of the three, and the influence the other to have on the reference charge. Now let's take the first question as we move right away. The question says calculate the net electric force exerted on a particle of charge minus 4 microcoulombs due to the influence of charge plus 5 microcoulombs and minus what 3 microcoulombs at a distance of 20 centimeter and 50 centimeter respectively from it. Now what the question is saying is that we have minus 4 microcoulomb. Then they said calculate the net electric charge exerted on a charge minus 4 microcoulombs due to the influence of what? Of 5 microcoulombs plus and minus 3 microcoulombs at a distance of what? That is to say, one is what? If you check the distance, that is 20 centimeter. This is one of the charge. Then the other one is what? Is minus 3 microcoulombs. And it is also measured at what? Distance of what? 50 centimeter from what? From this what? 4 microcoulombs, minus 4 microcoulombs. That is what the question is saying. Now, it now says we should calculate the net electric what? Force on this particular minus 4 microcoulombs. Now, what I want to do is was very easy. Since we are calculating the net force on this due to the influence of this and this according to the question. Now, what I will advise us to do is simply what influence will, let's say this one is charge 1, let's call this one charge Q2, let's call this one Q1, and let's call this one Q3. Now, the question is, what will be the influence of what? Charge Q2 on Q1. It will be an attraction force because Q12 is a positive charge. So since Q2 is a positive charge, you should know that like charge repel while unlike charge attract. So plus 5 microcoulombs will attract what? Minus 4 microcoulombs. So it then moves towards the direction. Although it also creates an attraction force, which is, but we are not concerned. We are concerned about the net force on this. So what influence will this one have on this? This, let's call this one F12. F12. Now, what influence will this minus 3 microcoulombs have on minus 4 microcoulombs? It will actually be repulsion because this is minus, so they will repel. So in that case, we are going to have it as what? Repulsion, like this. So having got, let's call this one F13. So we have F12 and F13 on the charge Q1. So in this case now, because they are moving in opposite direction, the question you're going to ask yourself next is F12, the force of 2 on 1 and the force of 3 on 1, which of them is bigger or which of them is higher? Now, because of the distances of what, or the distance of 5 microcoulombs on minus 4 microcoulombs is very small compared to what? This, which is 50. I will say F12 will be having a higher force than F13. So that means the net force here, having it in mind that they are moving in opposite, look at it, one is going this way and the other one is going this way. So opposite direction. So I want to say F12, which is a bigger force, minus smaller force F13. So I haven't done that. We are going to use what? K absolute of Q1, Q2, all divided by 1, 2 square minus F K into bracket Q1, Q3, all 1, 3 all square divided by 1, 3 all square is equal to what? The net force. You just put in your value and you get your final answer. So what we are going to do now is that let's put 9 times, don't forget our K. K is what? 9 times 10 raised per 9 Newton meter square per what? Volume. That is what our K is given in the question. So that is to say 9 times 10 per 9. Then Q1 is what? What is Q1? Minus 4 times 10 power minus 6. Micro is minus 6. Then times what? Again, what is Q2? 5. Absolute of 5 times 10 power minus 6. Or divide by what? By, let's say the distance is what? 20 centimeter. So since it's 20 centimeter, what do? You actually what? Divide by 100 to convert it to meter. So if you divide by 100, 20 centimeter divided by 100 will give us what? 0.2. 0.2 square. So you get the answer from it. That will give you F what? 1, 2. Now let's find F 1, 3, which is similarly going to be what? 9 times 10 power 9. Absolute of what? 1 again. 1, 3. We are looking for 10 power minus 6. Absolute of what? That is Q3 minus 3 times 10 power minus 6. Then divide by what? What is the distance apart? That will be 0.5 what? Square. So let's find the value. And once we get the value, we can now interpret our answer, put it into this equation. So what I want to have now is what? 9 times 10 power what? 10 power 9. Okay, multiply by what? Times 4 times 10 power what? Because minus will be cancelled by the absolute. This absolute will not have effect. So minus 6. Okay. So times what? The next one is what? 5 times 10 to the power minus 6. As I'm doing, you also do it so that you can confirm your answer. So divide all divided by what? 0.2 all square. That means 0.2 square. So what I want to have is what? 4.5. I want to have 4.5 Newton. Then we'll do similar one again, similar thing. Let me just adjust my 5 to 3. So 5 will now be 3 because that is only the absolute will be cancel. The absolute will cancel the minus sign. The absolute also cancel the minus sign here. Then the denominator will now be what? Divided by what? 0.5 all square. So what do we have now? I would have 0.432 Newton. So if you do it actually well, this is what we are going to have as our answer. Okay. Now, I haven't done that. What you are going to do now is this. You have gotten your answer for the two of them. This F12, this F23, F13. So you put it there, subtract 4.5 minus what? 0.432. So you subtract them. So what do? You subtract. Okay. Sorry, let me confirm the first answer. It's like the answer to that first one is wrong. Let's be sure. Let's be sure of the answer. Okay, it's correct. So now 4.5 minus 0.432. 0.432. I want to have 4.068 Newton. That will be our answer there for that first question. 4.068 Newton, which are probably 4.07. So 4.07. So answer will now be equal to what? 4.07. Now, what is the nature of this particular system? Now, we have an attraction force closer and a positive force farther. So our answer can be what? Attractive force will dominate the system because it's even higher. Look at 1, 2. 1, 2 is what? This is an attractive force, while this one is repulsive. So if I should ask which one is bigger, you say the attraction is bigger. So that means the answer will be what? Attraction force. In other words, this answer might not be like this. It can also be equal to what? In terms of magnitude and direction, minus 4.07 Newton. Look at it. Why is it minus? I told you in my last video concerning three charges using principle of superposition that when you have a minus sign, it indicates attraction. But whenever you have a plus sign in your final answer, it indicates what? Repulsion. I said and emphasize on it. I think this answer for the first question is very, very clear. So we can move to the next question. So please, I'll permit me to clean this. Now, we want to move to question number 2. Question number 2. Two questions. It says 2 point charges are located on the positive x-axis of a coordinate system. Please, as you are watching this video, just like and share and subscribe. System that Q1 equal to what? 1.0 microcoulomb is 2 centimeters from the origin, and Q2 is equal to minus 3 microcoulomb is 4 centimeters from the origin. What is the total electric force or total force exerted by these two charges in the third word, on the third word charge Q3, which is equal to 5 microcoulombs located at the origin? I think let's take it one after the other from the statement, line by line. 2 charges are located along the positive word, on the positive x-axis. So this is let's make a sketch. This is the positive x-axis. Okay, let's say this is the origin. Let me take this one as the origin, as the question said. 0, 0. This is the y and this is x. So we have more concern about the x. Okay, let's say go along the located on the positive x-axis now of the coordinate system, that Q1 equal to what? 1.0 microcoulomb is 2 centimeters from the origin. So this, let's locate from the origin to this place. Let's say 2 centimeters from the origin. Okay. And I'll say what? And charge Q2 is equal to minus 3 microcoulombs is 4 centimeters from the origin. Okay, that is this Q1, and that Q1 is 1.0 microcoulombs, as the question says. Q2 is what? Minus 3 microcoulombs is 4 centimeters from the origin. Okay, now this is the origin. Now say what? What is the total force exerted by these 2 charges on the third charge Q3, which is equal to Q3 is what? 5 microcoulomb. Okay, so now we can now go ahead to analyze. Located at the origin. Now it's located at the origin. Now look at the board. Let's analyze this question. Very interesting. This is plus, it will repair this. Okay, go this way. This is plus and minus plus, it will move this way. Okay, assuming here is plus, it will have moved this way, which you just add them together. Assuming this is plus, it will have also repaired, and probably the two forces will now be moving in the same direction. Probably now it will now be addition of the two forces, but now this one is moving like this because this is unlike charges between these two. This plus, this plus. So now we have gotten our direction. This is what attraction. Let's go. This is what Q2, and this is Q3 according to the question. You can look at the question there. Then this one is what? What? Between 3 and 2 attraction. Then the portion between this one is what? The portion between 3 and 1. So this is what we have. Now, I haven't gotten this one now. What is the net force? The net force will now be equal to F31, which is bigger. Why? Why am I choosing F31? F31 is between what? 3 and 1, which is closer for distance, creating a higher force. Don't forget, F is inverse proportional to what? R squared. So the closer the distance, the higher the force. The closer the what, or the smaller the distance, the higher the force. So when two charges are close to each other, it tends to increase the electrostatic force. So which is F31 minus what? Why am I subtracting? Because they are moving in what? Opposite direction. One is going this way, the other one is going this way. So F32. So we are going to have what? Calculate F31 first. So F31 will now be what? K, Q or 3, Q1, all divided by what? R31 square. Get me the answer for that, which is what? 9 times 10 to the power 9. Absolute of what? What is Q3? 5 times 10 to the power minus 6. What is absolute of 1 times 10 to the power 3, 1, okay, minus 6. All divided by what is distance apart? 0.02 all square. Don't forget, you convert to meter by dividing by 100. To convert centimeter to meter, you divide by 100. So you get your answer there. Then F32 will now be what? KQ3 Q2 divided by R32. So you get it. That will give me what? 9 times 10 to the power what? 9. Absolute of what? Again, 5 times 10 to the power minus 6. Multiplied by what? Absolute of Q2 is what? Minus 3 times 10 to the power minus 6. Divided by what? 0.04 all square. We still get the answer for that. Then, having got the answer for the two of them, then we'll go ahead to solve our final solution. Now, let's press our calculator. If you have a calculator with you, just want to get our final answer. So 9 times 10 to the power 9 multiplied by what? Multiplied by what? 5 times 10 to the power minus what? 6 multiplied by what? 1 times what? Times 10 to the power minus 6. Don't forget, the denominator is what? 0.02 all square. So you get your answer. The first answer is 112.5. 112.5 Newton. That is F what? 31. This one is F31 first. That is not our final answer. What about what? The second one. Okay, we don't forget the minus sign will be eliminated because the absolute will cancel it. I use absolute because I want all my answer to give me positive. Then so I can analyze the direction myself. So this one will give me what? 3. Okay, sorry. I need to divide by 0.04. 0.04, not 0.02. So that will give me what? 84. 84.375 Newton. Now, you now put it here. This one is what? 112.5 Newton minus what? 84.375 Newton. So what will be our final answer? So our answer will now be what? 112.5 5 minus what? 84.375. So I would have 28.125 Newton. That would be our force. Now, what is the influence? Well, what is the nature of this force? So F net is what? 28.125 Newton. This F32, don't forget. Now, I haven't gotten it. What is the nature? I want to ask you, what is the nature of this? Three charges, we have more, we create more, the nature of the what of the three charges on Q2. The nature of this one and this one on this one. Which one will dominate this particular system of charges, of three charges? It will be what? Repulsion. The reason being is this repulsion force. Repulsion will be the dominating what? Force. Yeah. Why? If you check, the F31 is created by what? By a repulsive force. F31 between 1 and 3, they are like charges, which is they repel. F32, they are attract. So which one is bigger? The F31 is bigger because it's having a smaller what distance between them. So that one is what very, very clear. So we go to the last question for this section. The last question. We take the last question, then we know we are true for what? Three charges. We know we are true for three charges. Now, the last question now says, let's go to the last question. This one is a little bit different from others, although the concept is the same. Now, it said two charges are placed in the x-axis. Let's go ahead. This is the x-axis. No. The x-axis Q1 is equal to 6 microcoulombs plus 6 microcoulombs at x equal to 0. Let's take here to be 0, s equal to 0. Let me take here, s equal to 0, which is what? Plus 6 microcoulombs you play there. Yes. Then another one is what? They said what? And Q2 is minus 8 microcoulombs, as you can see. We also go through the question as I'm teaching. We go through the question. Now, what did you say? Q2 is what? Minus 8 microcoulomb is at what? S equal to what? 0.6. That means from here to this place is what? 0.6 what? Meter. It's placed there. Okay. That is what? Here is what? 0. What? That means 6. Which is what? Minus 8 microcoulomb. Okay. Now, what did he say? Let me drag it forward. Now, what is the next thing? Now, they say what? Where must a charge, a positive charge plus Q, be placed if is to experience a what? A force of 0. If is to experience a force of 0. Where can the what? A positive charge be placed in this field so that it will experience a force of 0? First of all, we have three options. We can, okay, let's say this one is what? Attraction between this one. So there is what? Variably what? A force in between these two charges. So, and if there is a force existing here, to create a net force of 0, there cannot be neutral point here. Neutral point will always be created where force is not what? Existing. Okay, if we want to test, let's say we can push it, we can put the charge here. Let's call this one A. We can put it here. Positive charge can be here. It can be here, positive charge. So it can be here. Okay, let's say we put it here. Maybe unknowingly. Now, if you put the positive charge here, you know what it will cause? The positive charge now, the effect will be that it's seeing the negative side from the negative charge from the right hand side. It will attract it. And when you put it at the middle, it's seeing the positive charge from the left hand side of it, which is positive and positive, will repel. It will also go like this. It will repel towards this direction. You see the effect of putting it at the middle. The two forces, the two directional force, or the force that will be created by this and this on the charge that you place plus Q will be positive. There is no way these two can give you 0. It is not possible for two forces moving in the same direction to create a force of 0. For example, if I have 4 Newton and 4 Newton, if they are moving in the same direction, is it possible for them to be 0? No. But if I am having these two forces in opposite direction, maybe 4 Newton in forward direction, 4 Newton in backward direction, automatically we yield 0, because 4 minus 4 is 0. But you cannot have 0 when two forces are moving in the same direction, irrespective of the value. Now, please, that is just that. That one is what? No go area for us. That means, now, we have a what? We place the positive charge, we remove it from here and place it here. Now, when we place it here, we notice that, okay, positive and what? Positive and negative and positive. We create an attraction like this, okay. Positive and what? And positive, we create a repulsion. Positive and positive, we create a repulsion, okay. This one is making sense. Let's come here. Let's see, check. Let's go. This one is B. I've talked about A. So now, let's say this one is C. Okay, now let me see the point C. Let's place it at point C. This is positive, this is positive. It will repel. I have to test C first, because I can put it here, here, or here. This one is not possible. This one is possible because the forces are moving in opposite direction. Okay. Now let's say this one will repel this one like this. Okay. Now negative and positive. What influence will this one have on this charge that will place in field? It will be also what? Attraction. So since it's attraction, this one is possibility, this one is possibility. That means C and B, that becomes our what? Challenge. Now, which one do we now consider? Which one do we go for? Because this one is showing opposite direction, which is a possibility that it can be there. It's also showing what? Possibility that it can be here because it's going in the opposite direction. But I will advise you, whenever you get to this case, where a critical stage like this, and that this one is possible, this one is possible, it is better you place the charge closer to the what? The smaller charge in magnitude. I'm not talking about what? Minus. In magnitude, that means this one, what they are 6, this one is 8. Which one is smaller in terms of their size? Is this one. So I'll place it here. This one will need it more. So I will not consider this position, rather I will consider this position. So in that case, let us what? Consider this point. And let's place it at X from 0 mark. X meter from 0 mark. Now, if it's X distance, which is meter from 0 mark, we can now solve. So this is our positive charge. Now, the net force on this one must be equal to what? 0, according to the question. So that means that this and this on this charge create a repulsion. Let's say is Q1 and this is Q2. Then Q1, let's call this one now Q0. So Q1 on what? Q0 is what? 0, 1 is up like this repulsion. While Q2 or Q0 is what? F what? O2, which is attraction. Is attracting. So we are having something like this now. Look at it. FO2 created by what? This one is created by Q2. While this one is what? FO1 created by Q1. This is repulsion. So the net force here, the two of them must be equal, since the net force here is what? 0 Newton, according to the question. Now, if the net force is 0, it means that the force acting this way and the force acting this way must be equal, must be the same. That's why I equate them to be equal. Now, what is FO1? FO1 is what? K, Q, not, which is Q, absolute of Q1. Q1 is what? 6 times 10 by what? Minus 6 divided by what? What is the distance apart between Q0 and Q1? It is what? X squared. Then what about between Q2 and Q0? Now be what? K what? Q what? Absolute of what? 8 minus 8 times x power minus 6 over what? What is the distance between this and this one now? Now from here to this place is 0.6. Then from here to here is x. What will now be total distance from here to here? That means x plus what? 0.6. That means s plus what? 0.6 all squared. Now we can now solve. Now this will eliminate this. This charge will also eliminate this charge. So what we are left with, okay, I think this one now will now remain what? 6 times s power what? Minus 6 over s squared. See equal to what? 8 times s power what? Minus 6. Absolute will kill the minus sign over what? S plus 0.6 all squared. This we cancel this, okay? 2 can go here. 2 in 6 will give us 3. Then 2 in 4 will give us what? 4. So we can cross multiply. It now become 3 into bracket what? 3 times this. S plus 0.6 all squared. Then 4 times what? S squared. Now let's play with it now, this time around. Now, if you play with it now, open the bracket first by what? Using the expansion. Square this, s squared. Where you square is that s squared. X times 0.2 times 2. S times what? 0.6 times 2 will give us what? 1.2x plus what? 0.6 squared. Now square this side, which is what? 0.36. It's got to 4x squared. Now let's confirm it so that we can 0.36 is, yes, I'm correct. So now let's open the bracket. If you open the bracket, what do you have? This one now give us what? 3 times, we have 3x squared. This one 3 times we will give us what? 3.6x. Then 3 times this we are going to have what? That should be 8. Carry 1, 6, 9, 10, 0. Then 3.0, that is 3 times what? 0.36. That should be about what? 1.008. Okay, that's 1.08. Then sure equal to what? 4x squared. Okay, now having done that, now what do we do? Collect like let this one move to the other side. Let's move this one to the other side. Let this one move. So I would have what? If this one move to the other side, we have x squared, because 3x squared removed from 4x squared, we have x squared. This one move, we have minus 3.6x. This one move, we are going to have 1 minus 1.08 is equal to 0. Now, anything we solve for x now, because we are looking for what? The position. Where can the what? The charge be placed? Where? The position. So, if you solve what using quadratic functions or quadratic formula, or use or solve your what through simultaneous equation, anyhow you want to solve it, you will discover that you are going to have it as what the one will be giving us negative and one will be giving us positive. So that is how we are going to. The one that gives us negative, we actually bring our answer. Sorry for the delay. So we are going to have 3.8. One of them is S is what? 3.8 what? 7 meter. While the other one is giving us minus. It can never be minus. So this one can, okay, let's say approximately what? 3.9. 3.9 meter. But don't forget that we added this together because the distance from here is 6, 0.6. So the distance apart from this Q2, which is this O2 to O, is the distance. Then the distance from here to here is S. So it's very easy. So cross multiply. That's what we did. Then open the bracket. This times this will give us what? 2 times what? 1.2 times 3, 3.6. Then take it to the other side. Then you get your what? Answer. So it's very easy. So the one that has what? minus sign is what? Minus 0.27. You throw it away. It's because S can never be negative. So our answer now will now be what? Equal to what? 3.9 meter, which is the position where the charge can be placed without what? That will give zero force, and it must be placed close to what? Plus what? 6 microcoulomb, the smaller charges. So when we shall see again, please ensure that you always stay tuned by pressing your notification button to also subscribe so that you can watch our video. Thank you for watching. God bless you.